back. Now we'll try some searching algorithms. These are very important algorithms. You will encounter these when you go through your programming classes. Locating an element in an ordered list is a searching problem. The general search problem can be described as follows. Locate an element X in a list of distinct elements A1 through AN, or determine that it is not in the list. So you have a list of distinct elements and you want to see whether X is one of those elements. If it is, you want to identify the location, and if it is not in the list, then you want to be able to say so. The solution to the search problem is the location of the term in the list and is 0 if X is not in the list. You see, my numbers are now, my elements are numbered 1, 2 until N. So if X is not one of these, then we will say return 0. If X is A1, you will return 1. If X is A2, you will return 2, and so on. So you're going to return the location, and if X is not here, then you're going to return 0. Now there are several search algorithms. The very first is the linear search or the sequential search. Here we first begin by comparing X with A1. When X is A1, the solution is the location of A1, namely 1. When X is not A1, we compare X with A2. It should be 2 here. If X is A2, then the solution is a location of A2, namely 2. Continuing this process until a match is found where the solution is located of that term, unless there is no match, in which case the location is 0. Here is the pseudo code for linear search. Algorithm 2, the linear search algorithm. Procedure is called linear search. Linear search takes an input X, which is integer, and a list of distinct integers A1 through AN. So, start with I equals 1. I is the location 1. While I is less equals N, that is, while you are still within N, 1 through N, and if X is not AI, increment I. If I is less equals N, then location is I. Else location is 0, return location, where location is the subscript of the term that equals X or is 0 if X is not found. So the way we go through this linear search is, suppose these are my distinct elements. Okay, so say X is I don't know, 3, and these are the list of elements. In other words, X is 3, A sub 1 is 10, A sub 2 is 12, A sub 3 is 1, A sub 4 is 3, A sub 5 is 9, A sub 6 is 20, A sub 7 is 13, and A sub 8 is 15. So this is the list of numbers, distinct numbers, And this is the one that we are locating. So to begin with, what does it say? Start with I equals 1. That's your first assignment. Okay. So if x is a sub 1, then you're going to be done. So you're going through this. If x is a sub 1, you don't have to search anymore. You understand? So you are going through a loop as long as x is not an AI. So here is 3, which is not a1. Correct? X is not equal a sub 1. All right. So that condition is satisfied. Is 1 less equals n? N is 8. You see the highest. So I is less equals 8 and x is not equals a1. Well, because this happened, what do? We increment I. That's what it is. Increment I by 1. So you take the original I value and increase it by 1. So now I is 2. Is I less equals 8? Yes, it is. I is now 2. It's less equals 8. And x is not a 2. X is not a 2. So increment I. Okay. Is I less equals 8? 3 is less equals 8. But is x equals a3? No. It is not a3. So what do we do? Increment I again. Now I is 4. Is I less equals 8? Yes. Is x equals a4? Yes. So this condition is no longer satisfied because x is equal a4. All right. And this is an and. You need both in not equal and less than or equal 8. Well, x is equal a4. So we stop the while loop and go to the next line. What does the next line say? Is I less equals n? Is 4 less equals 8? Yes, I is less equal 8, right? So location equals I. I was 4. Okay. Now, if you had gone through this business and you had ended here 8 and x is still not a 8, well, that means you have not found x here, in which case location would be 0. That's what this line says. If I is less equals n, then location is I, else location is 0. So either way you find a location. If x is in the list, you have an exact location. If x is not in the list, you are saying location is 0, and whatever is the location value, you are returning it to the user. Okay, you are returning it to the person going through this algorithm. Okay, so that is the first linear search algorithm. We'll continue next lecture with binary search algorithm. Until then, bye.